In question 23a, we're asked to complete the table by determining the extension with a tension of 8.0 newtons. Well, up to 8.0 newtons, if you look at the strain, which is change in length over original length, it goes up in proportion 0.2 times 10 to the minus 3 each time. It changes for the next reading at 9 newtons, but that means that the extension must be going up in the same increments as well. So we're having increasing by 0.4 times 10 to the minus 3 each time. So the 8 Newton value should be 1.6 times 10 to the minus 3. In part B, we're asked to plot the data point corresponding to 5.9 newtons and draw the line of best fit. And then for part 2, to find the Young modulus. Well, this is the gradient of a stress against strain graph. And the figures I got were 7.95 times 10 to the 7 over 0.9 times 10 to the minus 3, giving you a Young modulus of 8.8 times 10 to the 10 pascals. In part C, we're told the micrometer screw gauge used to find the diameter of the wire had a zero error, meaning the recorded diameter was larger than it should have been. We're asked to discuss how the actual value of Young modulus would differ from the value calculated by the student. Well, Young modulus is equal to stress, which is force over area, divided by strain, which is extension over length. We can rearrange this to force times length over extension times area. So if the diameter was less, the area would be less, and that is a term on the bottom here, which would lead to the Young modulus being greater than calculated. This is because it would give a greater gradient on the graph.